We'll be working on simplifying double angle formulas. So we got like a cheat sheet here. Apparently I drew all over it and then saved it. I don't know why I did that, but it's still relatively legible. What we're focused on in this case is our double angle formulas, which are right here. Yeah, they're all over here. So what we need to do is kind of figure out which ones we can use to apply to this question. So are there any that have a relationship of sine some angle times cos some angle? This one here, the very beginning, has sine times cos, okay, but there has to be a 2 in front of it. So we're going to kind of keep that one in mind. That could be helpful. This one has a subtraction sign between. I can't right away do anything with that. I might be able to manipulate this using some of these types of identities here, but let's try to go with what's easiest to start. Subtraction sign, and this is a fraction. So none of these seem too simple at the beginning. This one we can probably get to work. So what we're missing right now is we need the value in front to be 2, but we currently have a 5. And it's not exactly what we need. So how can we go about doing this? There's a couple ways we can do this. One of these is we can try to decompose 5 into a factor of 2. And what I mean by that is I could say, what is 5 divided by 2? Gives me 2.5. So in other words, 2 times 2.5 gives us 5. So I can split 5 into that if I want. We'll show you that as one of the roots. So let's say 5, we're going to replace 5 now with 2.5 times 2. And then we're just going to write out the rest of this. Sine 2x cos 2x, okay? So all we did there is replace 5 with these two values. And now what we've miraculously done is we've kind of set up this relationship here. Now, it doesn't technically matter the order of multiplication. Think of these all as separate terms, and I can rearrange them all I want. There's a property called associative that allows us to do that. This is great. I've set up this relationship, which is really similar to this. And what it says is that is equal to sine 2 theta. So think of it like you've taken this 2 and kind of multiplied it by whatever the angles are in there, and it's only left with sine. There's no longer a cos. So we can replace this with sine, and then 2 times 2x will give us 4x. There's nothing else left. The cos is gone. And I have 2.5, which if I want, I can convert into a fraction. I think the fraction reduced is like 5 over 2 sine 4x. Okay, that's one way. Another way we could kind of go about this, I'm going to do the exact same question. 5 sine 2x cos 2x. And just really doing the exact same thing. I'm going to multiply. So here's a term, here's a term, here's a term. I'm going to multiply by 1. Doesn't change anything. More than acceptable practice because I'm not actually changing anything. Okay, but 1 is not really going to help us. Remember how we said we needed a value of kind of 2 to be snuck in here? Well, let's no longer have it as 1. Still going to keep these separated so you can see that they're terms. Instead of being 1, let's call it, where we'd have a value of 2, let's call it 2 over 2. That's the equivalent of 1. Right? And not just 2 over 2, let's actually decompose this just like we decomposed that 5 before. 2 over 2 can be written as 2 times a half. Well, now that I've done that, I now have 5 times sine 2x times cos 2x times 2 times 1/2. Now, that associative property comes in really handy here. Think of it like we can kind of interchange whatever spots we want here. I'm going to move this 2 to be in front. Okay, I can keep the half on the outside. It's not a big deal. Or I'm going to move it to the front with the 5 because that's a constant. Okay, so we now moved a half to the front times 5 times 2 times sine 2x cos 2x. And lo and behold, we've now built this relationship again. That same idea where we take that 2 and think of it like we multiply it by the angle inside sine. The cos kind of falls off. We already talked about what the property was, right? So we're left with sine 4x. And a half times 5 is 5 over 2, which is exactly what we got before. Tactically same thing we did, just kind of different theories to start it off, okay?